Hello all, today we'll be solving the trapping rainwater problem. Let's get right into it. I'm just going to explain the solution here on my iPad. So here we are given a list with the height. So what we want to do to solve this problem is we're going to use a two-pointer, which is like this, a two-pointer solution. What we're going to do first is we're going to assign a left max and a right max. And a resolution 0 is going to equal here. And what we're going to do first is we're going to assign the left pointer to 0, which is there. But I'm not going to put the arrows here yet because we haven't even referenced that left side yet at all. And the right we want equal to here. So clearly we want the length of the height and -1 to access the last part of that list. And then what we are going to do is, in the first part of our code, what we're going to do is we're going to set the left max to the max of, oh, first you have to initialize it, sorry, my bad. Left max. On the very first run, it's going to be equal to the height of left. And on the height of left, since it's 0 right here, it is going to be 0. And right max, if we look at it, right max, height of right, it is right here at 11. Right max, 11. And we're going to initialize the result with 0. And now what we're going to do is we are going to start our loop. And what we want to do is we want to start it at here and here, which is our right and left max. And what we're going to do is if the right pointer here is greater than the left side, we are going to add 1 to the left side. Add 1 to the left pointer. But I'm not putting the arrow over here yet because we haven't even referenced it yet. And then after that, we're going to go through the loop again, and we're going to say if the right side, oh sorry, I'm sorry, let me back up one. And after we add 1 to the left side here, we are going to check our left max and say if the max of left max and left, we're going to choose which one, and left it is. So it is here, and that is 1. And now to get the result, we're going to say, hey, we're going to take the current height at 1 here, which is this, at the negative of left max, and then we're going to add it to the resolution. But since 1 - 1 equals 0, that is why it'll stay at 0. And now we're going to go into the second part of this. So we're going to go back to the top of the code here, and we're going to do this again. And if the right side here is greater or equal, less than or equal to the left side, then we're going to, now this is going to be the we're going to do right negative, which would lead us to 10, since it was at 11 before. And now we're going to check the right max, which is currently, I don't know what's that right now, sorry. The right max, which is currently 1, with the right at the right max index, which is here. Not right max, sorry, which is here. And we're going to compare this height here to the right max. And since 2 is greater than 1, it's going to be here. And we are going to see the result. The current height at this index here, negative the right max, and 2 - 2 equals 0. And we're going to keep doing that over and over and over and over and over and over and over till these two meet up, but they cannot overlap. And now we can write the code for this. So we can keep this open just to reference it if we'd like. So what we're going to do here, oh, I guess we're not going to keep that open. Let me just move my iPad. What we're going to do is we are going to set the left equal to 0, the right equal to the length of height, -1, and we're going to set the left max equal to the height of left, which is going to be 0 for now. Right max equals the height at right, which is what we saw, which is 11. And we're going to set the result equal to 0 right now. And since we cannot have the two left and right side overlap, while left is less than right, we are going to see if the left max is less than the right max, we are going to do left plus equals 1. Sorry if I said plus earlier. I've been doing a lot of coding in Java for school. And left plus equals 1. And we're going to check the left max and reassign it to the max of the left max and left. So right now it's 0, but since we moved it over here, because we're checking the, we're checking the height at left, which is here. 1, 1, 1. See that? The new left max is going to be 1 on that first iteration. And I shouldn't say iteration, this isn't a for loop. And then we're going to see the result, which is plus equals the left max negative the height at left. Should be actually, okay, and then if left max is greater or equal to right max, we are going to do right negative equals 1 and right max equals a max, same thing as above, right max height right, and the result plus equals the height at right negative the right max. And then we are going to return the result. And let's see what we get here. Oh, -8. Yikes. Left max. Let's try this. Ooh, yikes. Went wrong here. Let's see my solution. Plus equals. Oh, my bad. LF. I missed LF. There we go. I'm sorry about that. And there we are. That is the result. And if you look, submission, we're faster than like 87.63. Let me see. Ooh. In memory, it beats 93.05. Very nice. And that's it.